one to go. Lucky last. Taryn Miller from the Institute of Fundamental Sciences. The title of the presentation, Bioprotectant Capabilities of Endophytes in Ryegrass. Welcome, Taryn.
Grass. Something that seems so simple, yet is immensely complicated and very important. We, as New Zealanders, rely on grass to feed our livestock, which in turn supports our agriculture, that in turn supports our economy. This is why the loss of grass through insect damage, that may seem trivial, can start a detrimental domino effect. Currently, we use chemicals to combat these insect populations, and though this is effective, it does tarnish our clean green image, increase insect resistance, and is harsh to our environment. Thankfully, Mother Nature has provided an alternative strategy, the endophyte. Endophyte, which means inside plant, is a type of fungus that forms a beneficial relationship with grass. In this relationship, as magnified here, the grass provides an environment for the endophyte to live in, while the endophyte produces bioprotectant proteins that either kill or deter insects. This strategy is the focus of my PhD. I'm working with the endophyte strain PN1, which is neuroprotection against both the cutworm moth and the stem-boring fly. My mission is to identify the protein or proteins responsible for this bioprotection, adding to the arsenal of weapons used in agriculture. First, I recreated a battlefield scenario where in a glasshouse, grass containing either PN1 or other endophytes of interest were exposed to the insects. As predicted, PN1 was shielded, while the other grass sustained insect damage. This highlights the presence of a PN1-produced protein. I have a candidate protein, and this is the focus of my future work. Next time when I recreate this battlefield scenario, I will disarm PN1 by genetically manipulating the fungus to prevent protein production, and rearm PN1 by re-establishing protein production. I predict that the disarmed PN1 will sustain insect damage, while the rearmed PN1 will be able to maintain that shield. This will prove the protein's bioactivity. With a new bioprotectant protein identified, we can see other endophytes in our database also produce this shield. So, next time you see a field of grass, just remember that out there are friendly fungi soldiers fighting a never-ending war against insects. Thank you.
Thank you, Taryn. Judges.
Yeah, Taryn, the practical value of what you're doing is obvious immediately, but what I really loved is how you took us through the phases of the research and showed the multiple ways that you're going about trying to prove your thesis. And I think New Zealand farmers will thank you as a result of that, so really well done.
Taryn, thank you very much. I loved the metaphor, the military metaphor that you're using. And I really like the way in which you are arguing that we can use a natural protectant, if you like. You know, we use the tools of nature to fight the battle, really. And the way in which you carefully stepped us through the control experiments that you would apply. So really clear application, obviously has national and international relevance, I think particularly for brand New Zealand, as you alluded to right at the start. So really clear, really cogent, really compelling. Well done, Taryn. Thank you.